The question for today is first unique number. You have a queue of integers. You need to retrieve the first unique integer in the queue. Okay, implement the first unique class. Okay, so it has the queue inside it. Okay, find unique path initializes the object with the numbers in the queue. So these are the numbers in the queue. Show returns the value of the first unique integer of the unique and returns -1 if there is no integer. So show first unique. Okay, show first unique returns the first unique number. Okay, and void add inserts the value to the queue. Okay, for example, add 5, then it will insert 5 to this queue. Okay, so let us go through this example once and then we will start coding. So what is this? This is okay, what is first queue? Okay, which functions are implemented? So this is the object implementation. Even though it is not mentioned, all are in capital letter, so we can say that first unique is an object. And then this is the function implementation, then all are the function implementation, whatever it returns. So implement the first unique, and first unique will return null, it return nothings. Then we have show unique. So in 2 3 5 we have first unique as 2. 2 is first and 2 is unique also, so it returns 2. The third is add 5. So to this queue we add 5 and it returns nothing. The next is show the first queue. So from here we need to show the first unique. So first unique is 2, so 2 is returned. Then we have add 2. So we add 2 to this. This is our next queue, and then it is saying show first unique. So when it comes here, 2 is the first but not the unique. 2 has appeared twice, so we will move forward. 3, okay, 3 is the first unique number that we can see, so we return 3 here. Then next is add 3. So to this queue we are adding 3. Next it returns nothing, so it returned nothing. And then is show unique, show first unique. So is 2 first unique? No, it appeared twice. Is 3 first unique? No, it appears twice. Is 5 first unique? No, it appeared twice. Is 5? No. Is 3? No. Is 3? Is 2? No. So it returns -1, that all the elements have been transversed and we are not able to find any unique number, so it returns -1s, and hence this is the output. Alright, now let us try to see how we will solve this problem. So we have a queue here representing, I have already made a queue for easy. Queue works on LIFO principle, so that's why it's last in first out. So if we say that this is queue, so this is the last of the queue and this is the first of the queue. This is first and this is last for this queue, so it is LIFO. So from last people will be added and from first people will be removed. So I think that we all better know this principle. So what happens here is, let us try to dry run this example only. Okay, so just let me do here what happens. First we will add 2 3 5. So 2 3 5 are in Q, 2 3 5 are in Q, and we need to add it to our uh, Q, right? But before adding this to Q, I need to know that how many times it has appeared. I also have to need to keep the count of the unique. So I have to maintain unique here. So suppose this is my unique, right? So I am just creating a hash table to keep a track of my unique. So here it is 2. What I will go before adding this element to the queue, once I see it, I say that I will increase its count to 1. I will increase its count by 1 in the unique count, and after that I will be adding this 2 to the queue, right? Now what I will do next, I will see 3, and I will first increase its count in unique count. So just don't call it count, unique count, just call it count, that is sufficient. So I increased the count here as 3, and now I add this 3 from ready state to queue, right? Now I have seen the other element, that is 5. What I will do, I will first increase it to 5, and then I will say that it is now empty and 5 has been added to the queue, right? Now what is the next function saying us? It is saying us show first unique. So what is the first unique here? The first unique here is 2. How we will say that it is first? It is appearing at Q0 position. How we will say that it is unique? We will go to count. Since it has appeared for the first time, it is unique, right? So what we are going to add, we are going to return 2 here, right? So initially I have defined the object, so it was null, now it's 2, right? And further we will be adding it. Now let's go to the second function. This is add what? Add 5, right? The third index is add, and add what? Add 5, right? So I am going to here say that I have 5. Now what I need to do first, that I have to increase the count of the 5 in 5. So count has been increased, and now I am saying that append this to queue, right? Now I will go to my next element. Next instruction is show first unique. So first unique, what is first unique? Is 2 first? Yes, 2 first. Is 2 unique? Go to count, see how many times it has been appeared. It has appeared 1, so yes, it is unique. So okay, for here last function, that was odd, I have to return null, and now the show unique is 2 again, right? Now let us see what is our next function. Our next function is add. What to add? Add 5, right? Okay, we have done this, we have shown the unique. Now this is the next function, add, and what we have to add? We have to add 2. So we are going here, writing 2, and we will increase the value of 2 by 1, so it becomes 2, and I need to add 2 here, right? So I have increased the value by 1, and then I will say that 2 has gone from here and into the queue, right? So since I have added, I am returning nothing, so I will add null here. Now next instruction is show first unique. Show first unique. So first unique here will be, first unique here will be, is 2 the first element? Yes, 2 is the first element. Is it unique? No, it is not unique because it has appeared 2 times. So what we will do, we will go here and pop 2 from here, right? And now we will see the elements, right? Below the remaining, in the remaining element, I see that 3. Now 3 has appeared. Is 3 the first? Yes, first. Is 3 the unique? Yes, it has appeared only one time, so it is unique. So I am going to add here 3, right? Now next element is add 3, right? Next element is add 3. So what I am going to do, I am going to put it 3 here. I will increase the count by 3 as I have seen it again, and then I will append it to Q, that is 3, right? And we will say that, okay, and we will return null. We have just added 3, right? Now next is show first count. When we will go to this instruction, we will say that, has 3 been appeared for the first time? No. So what we will do, so 3 is the first element, but it has not appeared for the first time. It has been appeared for 2 times, so it is no more unique. So I will just pop it out and say 3 is here now. Now next element is 5. So I have 5 here. What will I say? Is 5 first element? Yes. Is 5 unique element? No, it is not unique. It has 2. It has appeared twice. So what we will say, I will say, since it is not unique, I am just going to remove this and I am going to add 5 here. And now that you have seen that all are repeated elements, but still for the sake of this video I am completing this. So again I see 5. Is 5 first? Yes. Is 5 unique? No, it has appeared for it has appeared for 2 times. So what I am going to do, I will be removing this element from here, and I will be just popping it out. Now I will go to the next element, that is 2. Is 2 the first element? Yes, 2 is the first element. Is it unique? No, it is not unique. It has appeared twice. So what I will do, I will just remove this 2 from here, and we already know that this will happen because we have visited these for the first time. Okay, now I will go to 3. Is 3 first element? Yes. Is 3 unique element? No, it is not unique element. So I am going to pop this 3 out and the Q will become empty, right? 3. And now when the Q becomes empty, I will say that there is no element to return, and we will return -1 here. So this will become our answer, right? Now let us analyze the space and time complexity here. The space complexity here will be order of n for the Q, for storing Q, and the time complexity here will be order of n to traverse through all the Q, right? But we have observed one thing here, that once we get the repeated elements, we already know that the count has been increased by 1. So we already knew that everything now will be just popped off, but still we were just continue to do the operation of popping. So what I will be doing here is I will be converting it to unique Q now. I will be converting this to Q to unique Q, and let us restore the previous value. So this is the unique Q, and now let us transverse through this again. So count will be 0, right? This will be nothing, from the start, and let us just keep it aside that for first, for in case of q we get this time zone, right? Now we need to know that what we will get in priority queue, right? So let us just go through it, go through all this again. So let me mark it here as 1 2 3 4, otherwise I get confused that which number of operations are there. So here it is number 1 operation, this operation is 2, this operation is 3, operation 4, operation 5, operation 6, and operation 7, operation 8. So total there are 8 operations, right? Okay, so what I am going to do, I am going to do the first thing, that is first unique. I am going to add first unique elements, that is 2 3 and 5 here. 2 3 5, 2 3 and 5, right? Now what I say that, okay, I have seen 2, what will I do? I will just say that the count has been increased by 1. I will put the 2 out from here and put it here, right? Now I see 3, right? So I will, what I will do, I will go here, add 3, and I have seen 3 for the first time, right? So now 3 is removed and 3 has been added here in the unique queue. Now I have seen 5, so once I have seen 5 I will increment here 1, and now I will add, say that 5 has been added to unique queue, right? Once I add this, I have completed the first operation, and the return from this first operation is null, as it is just initializing the object. Now the second is show first unique. When we go here, we say that is 2 the first, yes 2 is first, is 2 unique, so we have to see that it has appeared only one time, since yes it is unique. So what I will do, I will return 2, right? Now I am going to add the next element, that is 5, right? So before adding this element to the queue, what I will say that okay, 5 has been appeared twice, and now since this is unique queue, we will not be adding 5 again. We will say that 5 has been appeared once and we are not going to add it again. That's it, right? Now next we have show unique queue. Sorry, so this function will return null. Add function, it returns null. Now next is show unique queue. Now we need to show the unique queue from these. Is 2 the first unique? Yeah, is 2 first? Yes. Is 2 unique? We will go and see here that yes, it is unique because it has appeared only for the first time. So we will go and add 2 here, right? Now the next operation is show first unique. The next operation is add 2. So what we will going to do here, we 2 appeared here, so I will increase the count of 2 here, and I will not be adding it to queue because I know that this is unique queue and we already have 2 in my queue. So what I will say here, I will say, hey, so what was this operation? Okay, this operation was adding 2, so we have added 2, and we will say null. This addition returns null. Now next is show first unique. So I will go here and I will say that 2 is the first element. Yes, is 2 unique element? We go and see that no, 2 has appeared twice, so it is not unique. So what we will do, we are going to pop this out. Okay, now I will go to this element 3. Is 3 the first element? Yes. is 3 the unique element? Okay, we go here and we see that 3 has appeared only one time, so I am going to return 3 here. Right, now next is add 3. So we go here, we add 3. That means if we have seen here, we will increase the value of 3 by 1, and then we will, what we will do, we will not add it to our queue because 3 is already been added, and it returns null. Right, now the next operation is show first unique. So once we get here, I say that okay, 3 is the first element, is it unique? So 3 has appeared twice, so it is not unique, right? So what I am going to do, I am going to pop this out, 3. Okay, now I am going again and I am saying that is 5 the first element? Yes. Is 5 the unique element? No, we have seen that we have seen it twice, 2 times, so it is not the unique element. So what we will do, 5 will be here, right? So the unique queue becomes empty and we will return -1, right? So this output remains same, count remains same by only changing this queue to unique queue. This was for queue, and let us write it for unique queue also. Unique queue, the space complexity will be order of n, that is queue is required, and the time complexity will be reduced to order of 1 for amortized analysis, because there will be elements but not all the elements that is present in the n, and for a very large amount of repeated element it will be order of this queue will change to order of 1 only, right? I hope this makes sense for you. So we are successfully able to reduce the time complexity in the second case by maintaining the unique queue instead of queue, right? So let us go and code this up. Let me just make it large so that it is easy to, I can just make one more of it. So I think that it is visible now. So what I am going to do, I am first going to say that I have nums. So okay, nums is what, I will first say self dot, I will be maintaining unique queue, so that unique queue will be a deck. So I think that you already know what is deck. That makes the pop left function in order of 1, that's why we use it. The second is self dot count, right? It will be a dict, and third is we need to add each element of this nums to our queue. So for num, in nums I need to add each element, so I have already add function provided, so self dot add num, right? Now what this self dot add does, before adding it to the queue, it is keeping a track of the count. So what it will do, it will say that self dot count of this value plus is equal to 1, right? Now I have to add this element to the queue only if it is a unique, only if it is unique. So if self dot count value equal to 1, that means if it is unique only then we are going to add this to our unique queue. Self dot unique queue dot append value. Right, now once these all are done, I have to do show first unique. So what is show first unique? I will look at the show first unique. Okay, so I will have queue here, and I will, so while queue, because in empty I will have to return null, right? So I will self dot queue, this should be there, and this self dot queue of value zero should be if this is greater than equal to 1. So if it is greater than 1, right? So if there is q and its first value is greater than 1, no, 1 in count, this first value should be greater than, so self dot count, and count of what? Count of this unique value. Self dot unique queue of 0. Right, so what I am saying here, if q exists, because if it does not exist I will have to return 0. If q exists and if the value of the first q in the count is greater than 1, that means it is duplicate. So what I have to do, I will have to pop it, and I have to keep on popping it until I don't find a unique value. So return self dot unique value 0 if self dot unique value is there. If the queue is empty, then I will return -1. Let us run this code, and yeah, it provides the right on. Let us just submit it, and yes, it is accepted. So you can see that this is pretty fast code, right? So if you liked my video, please subscribe it. If you have any doubt, you can answer it in the comments. Thank you.